Starting with our second session on satellites in 5G era and beyond, I request our chairperson, Mr. Anupam Shrivastava, former CMD BSNL, to join the stage.
Good afternoon, ladies and gentlemen. I think this session suddenly has become very important because in the morning the Honorable Minister mentioned about this session, satellite in the 5G era and beyond, out of all the sessions. So first and foremost, I would like to invite the moderator, Ms. Aarti Holla Maini, who is also Secretary GSOA, to the dais, please. She has kindly consented to be the moderator in the absence of Professor Abhay Karandikar, Director IIT Kanpur. Miss Aarti, please join us here. I also invite Mr. Harvinder Nagi, who is from Future Network Satellite Applications, Catapult UK. We spoke yesterday. I invite Mr. Ajmair Heer, Sales Director, Asia Pacific, Estrenes. Mr. Raghudas is not here with us this afternoon, so in his place I invite Mr. Alec Clymer from Estrenes. Suppose I have pronounced your name all right, you may correct later on. I also invite Mr. Abhik Saha, Chief Engineer and Head of the Networking and Wireless COE at Hughes Corporation, Mr. Abhik Saha. Well, before we begin, they say that knowledge speaks but wisdom listens, and that's what I think I should do as a chair for this session. But anyways, I can share with you little wisdom of hindsight, which includes my journey in telecom for almost 40 years. It started from number please days of manual exchange to work from ease days now. And then I was fortunate to rise to chairman of a government telecom PSU called BSNL in 2015. But let me tell you, in spite of my experience in telecom for 3 decades then, my knowledge of satellite was only to the extent that it has 2 L's, not 2 T's. Or is it vice versa? I'm still confused. But little did I know that soon I would be signing an exclusive agreement between BSNL and Inmarsat to bring in satellite communication with the ground earth station in India itself. Thereby, the satellite communication can be secured and monitored within the country. And little did I know that I am going to chair a session in Indian Space Congress on the subject of satellite in 5G era and beyond. Nobody is laughing these days. Once you retire, nobody laughs. Anyways, back in 2016, I still remember that we in BSNL were excited about the satellite business that could come to us, as we were the only authorized company to provide it. We were further looking to grow the business through in-flight connectivity solutions. Until recently, satellite was providing only complementary role to the communication in India, but things changed on 1st October 2022. Honorable Prime Minister launched 5G in India. I'm sure telecom history in India, when it will look back 1st October 2022, it will take it as one small step for 5G, as one giant leap for NTN networks. Why? Because 5G network expansion in India is just not possible without the NTN or satellite networks. With satellites in GEOs, MEOs, LEOs, and HEOs, and airborne HASPs, UVs, and drones, you name it, etc., etc., NTN network is going to now play a supplementary role in expansion of 5G. The digital divide between cities and rural areas and also within the urban areas in India can only be met through non-terrestrial network, including satellite. Incidentally, I was also spearheaded BharatNet project in India. Many must have forgotten, but as a line manager in Ajmair in year 2013, we conducted first pilot project of BharatNet. And then as CMD BSNL, we proudly connected first 100,000 gram panchayats with optical fiber cables. But I know how difficult it was to take the broadband to rural areas only with the help of optical fibers. Even after spending billions, it wasn't possible. The digital divide is going to be even more pronounced with the introduction of 5G. The three pillars of 5G, which is service continuity, service ubiquity, and service scalability, can only remain a dream without the supplementary role of NTN or satellite network. This session, therefore, becomes extremely important as it is going to focus on satellites in 5G area and beyond. So to conclude, we all know that the moderator was also mentioning some time back that 3GPP through various releases 16, 17, 18 and IMT 2030, which is laying a foundation of vision document for 6G or putting NTN or satellite as an integral part of their plan. I am told that various pertinent questions are discussed in this Space Congress, like whether frequency for space communication should be auctioned or not, or whether satellite players will eventually disappear like CDMA players, or whether MNOs in our country should tie up with only LEO players or combination of LEO, MEO, GEO, or a combination of them. And in this respect, this Space Congress is playing a very important role, and we must congratulate the organizers of this Space Congress. But to my mind, the more pertinent question is whether MNOs can themselves grow as NTN players. Or is it possible for NTN players to evolve as MNOs in future? I believe, looking at the mindset of the industry, I see a possibility of NTN players becoming future MNOs. Only yesterday, I was talking to Inmarsat guys, and they said that they are likely to put LEOs together with terrestrial 5G along with their already existing geo satellite constellation, and they said that they are going to call it orchestra. Similarly, many NTN players have planned to give the enhanced mobile broadband without the help of MNO players. As I have always believed, this is the time for collaborative competition, which we all know as co-opetition. In whatever is happening in this world now, and same is true for MNOs and NTN or satellite player in communication. Thank you very much. With these words, I hand it over to Aarti Holla Maini for taking this proceedings forward. Please come over here. Thank you.
Thank you so much, Mr. Shrivastava, for your kind introduction. And thank you to SIA-INDIA for inviting me to moderate this session on satellites and 5G. I'm Secretary General of GSOA, the Global Satellite Operators Association, and we represent 29 satellite operators, from the largest to the smallest, and as operators which are operating satellites in all orbits. Okay, it's working now. I didn't realize it wasn't working before. So when it comes to 5G, our sector has done, we have come leaps and bounds. A few years ago, in the association, we were not talking about 5G at all. It was just about satellites and the digital divide, the future of broadcasting, whether linear TV would remain, and so on and so forth. Meanwhile, GSOA has now issued its first paper on satellites and 6G. And that in an environment when 5G hasn't really become a reality for the masses yet. Will it ever? I don't know. But what we can say is that the sector has successfully done multiple trials and demos to show the feasibility of satellite for multiple 5G use cases. Within 3GPP, we have successfully seen 2 standards for 5G new radio over NTN and NB-IoT over NTN, which have emerged with release 17. And those standards, those specifications are now being enhanced with the work that's ongoing in release 18. So I would like to dive into an interesting discussion with our panelists today to see what does this mean for India? What does this mean in the satellite context in this continent? And so let's just dive in. We do have one presentation which Harvinder is going to give us from the Catapult. And I note that we are running a little bit late, but I hope nobody will mind if we overrun. Hopefully the discussion will be so interesting. But Harvinder, can I start with you just to set the scene a little bit from the Catapult side? I don't know if you want to start with your presentation before we jump into some questions. Yeah, please, let's start with that.
Hello, good afternoon, everyone. My name is Harvinder Singh, and I work for Catapult as an organization in UK. Excuse me, yeah. It's a government-backed organization, it's a non-profit making organization, and then we form consortiums from different funding streams to work on programs which are future networks. So if I just go through briefly on the overview of what Catapult do, and then we'll discuss briefly on the projects we are doing, again, integration of 5G and the satellites. So guys, can you hear me? Sorry, it keeps on coming back and forth. Right. So the brief overview is kind of a quickly overview of the Catapult, current programs in progress with 5G and SATCOM. And then I know that we are working on test beds, but eventually all this hardware which goes into space and at the terrestrial level need to be tested. So we also do offer some facilities which help them to simulate the space environment. So as I said, it's a very brief overview, and then I'm happy to answer any questions after this, either during or maybe after in detail. So I will be here today and tomorrow if you do have any questions. Okay. Right, so Catapult, a world empowered by space. So our catapults, there are 9 catapults. Ours is purely focused on space applications. Right. The core focus is to innovate for better world, and again empowered by space. So we're looking at space, and the potential to create opportunity is increasing in the greater agenda in many UK and global businesses. So what do? We learn, we connect, and we care. Okay. So what we do, we energize the market, we empower the technology, we enable businesses. Again, remember, we get all these skill sets within different academia and commercial world who have got range of skill sets to perform a research activity which need to be commercialized. So typical markets are, I'll just leave that here for you to just briefly look at it. We purely focus on the space side, but there are a variety of other markets we focus on. So our strategy vision is to accelerate the growth of UK satellite applications, and by focusing on three themes across the targeted marketing is empowering, energizing, and enabling. Okay, so our focus is to empowering organizations to realize the potential of their products, services by breaking down the barriers to entry. Energizing the market by unblocking latent customer demands and driving awareness of new routes to the market. Enabling growth through the connection and facilitation across the industry. Right, so this is purely focused on the UK market. So there's something we need to do to work with the Indian government and the UK government together so that we can provide the same kind of service and benefits. I do beg your pardon, I think something wrong with the mic here. Sorry? Yeah, it's the mic. It just keeps on stopping in the middle. Sorry? Yeah, I think. Well, so this is the part, sorry, I was trying to point on my previous slide, that Catapult do offer UK businesses and academia, but the similar kind of service could be done within India, and as long as Indian government are willing to come forward and then collaborate with us. So we do partnerships and collaborations. So these are typical achievements. These are the figures as of a couple of months ago. So I will just leave that for you to have a quick read. I think it's the fonts here. Yeah, even I can read it. So they are engaged over 35,000 businesses over time. And they worked in about 22 different countries as a Catapult. And they delegated over 200 external programs. Engaged with 118 universities, invested 35 million, and opened 5 more Catapult sites for a Center of Excellence. Okay. I'm happy to share these slides if anyone wants to have a copy of it. There is an email at the end. Feel free to, or I can leave with SIA, and they should make it accessible. Again, as I said, the focus is on partnership and collaboration, so I won't go into details of that. And again, this is purely focused on the UK, but we need to work on how we're going to work with the Indian government, and then we can happily provide the same support we provide to the UK businesses. Right, so the section I want to bring onto is some of the projects we are currently working at the moment, which is linking 5G and the terrestrial network, terrestrial networks and the SATCOMs. Okay, so there is a program going on at the moment. It's known under the name of 5G TINA. It's funded by ESA program ARTES for Advanced Technology 5G Network Function. It's a consortium of Catapult, University of Surrey, and a commercial partner company called Reply. They're a very software-based company. So the main role here is to create a test bed to moving the 5G network functionality into either LEO, MEO, and GEO, which is, Anupam sir just mentioned that. That's the focus here at the moment. And that's what we're trying with the University of Surrey under their platform, and they are the one creating a test bed at the moment. That will be the outcome of this program when it's finished. And part of that program is studying the feasibility of putting space-hardened semiconductor which can perform the same function. It's very annoying, actually, sorry about this. Performing the same function as it does on the terrestrial level. So we're trying to move the base station function, which you can get here at terrestrial level, and we're trying to move that onto space, which is a big challenge because of lack of semiconductors in that, with the same processing power. And it needs to go through various radiation spec and other space qualification. And that is a big challenge as it stands. Just to let you know that only processor which is available in the market in space world is a RAD 750, which was done by BAE Systems, and that was used on the Mars rover recently launched in 2018. So just imagine that's got a power of about 486, or a Pentium, early Pentium. And that's the big challenge, that you can't literally move straight away from terrestrial onto space within a span of 12 months or 24 months or even 36. So semiconductor industry has to work together in this particular challenge. Okay, so as part of the same program, we're studying different user cases. We're studying the emergency services. So typical SATCOM works on a bandpipe topology. You put in one frequency, and you get the other frequency out. Okay, so the way that we're studying the case study, there are 4 different case studies we are taking into account. One is the emergency services with a bandpipe and a processor on board. Again, the processor I mentioned is a big challenge in itself, because we can't get the same processing power in space as we can get at the terrestrial level. Second one is the IoT, Internet of Things, which has been spoken about quite a lot since yesterday. The third one is the broadband to moving platforms. And third one is the broadband to moving platforms, and fourth one is the multimedia using a multicast. Okay. The next program we're doing at the moment is connectivity solution to bring affordable, high throughput satellite and cellular data connectivity to end users. So basically using SATCOM to provide broadband services in an automobile. So that's another program I'm currently involved with. Okay, so we are working with different automobile companies who can literally accommodate the design of various aspects so that you can get broadband in a moving car. Okay, one of the questions I was asked by Aarti yesterday was on the cybersecurity issues and comparison with the cellular or terrestrial network. SATCOM is definitely prone to cyber attack. It doesn't have a priority over a cellular, but yes, there has been cases where satellites which got a reference signal coming from GPS, they have been jammed, I guess. There have been blackouts observed in different times, and that affects businesses. And I think it was reported I will say unofficially that up to hours of blackout has been observed. And then they're on constant threat because they're exposed to anyone, getting access. They could be rammed into, satellites could be rammed into with another satellite. So that has been observed as well. So yes, satellite is not as safe as, it can't be made a comparison that is safer than cellular or vice versa. Right. So one more thing I was asked to talk about was the quantum key distribution. Now, by no means I'm expert on this one, but I have some viewpoint on it. There are advantages in using that. It is definitely a secure communication method for exchanging encryption keys only between two shared parties, and it's definitely offers speed and security. The only disadvantage is you can't do from one to many. It's one-to-one only. Okay, and then QKD has been tried in SATCOM, but not been deployed yet. So it's still very, very early stages. It's not been examined it hasn't been deployed in the SATCOM yet. And in the UK, I know that there is a Centre of Excellence for quantum technology programs. So if there is interest from India, then we are happy to accommodate them and put them in the right channel for them to, work with the companies who are already working on this. These are my last couple of slides. I'm just going to run through some of the facilities we offer at Catapult. We offer in-orbit service manufacturing. Also offer a SATCOM on the move facility, which is under development at the moment. So even though we do develop hardware, and then before it's deployed and linking with satellite, we are creating an environment so that it's simulated with the effects of space. For instance, the second one here is called SATCOM on the move, which means that one of the projects I was discussing earlier in the CASIS, which uses one of the TRM modules on an automobile. So that could be tested using this facility's antenna test range, so that it simulates the effect of a moving car. So we have got this in-orbit service manufacturing commissioned already, and the second one is still under development. We do have far-field antenna range and the near-field antenna range to test with the SATCOM. Okay, and then in the bottom side, these are just some images of all the buildings for Catapult. The bottom image here, where we can see the arrow, we are working with OneWeb with their the terminals on improvement of their synchronization of reference signal.
Harvinder, could I just ask you a quick question?
Yeah.
I'm not sure if my mic is on. I'll try to elevate. I just wanted to get your perspective. Do you have a view on which 5G use cases would be the first that we might see in India? Do you have a view on that?
I think it will be the band pipe topology using probably LEO constellation or
Band pipe over LEO.
Yeah, I think that would be the starting point, because the processing power is not there at the moment to take it for these.
Excellent. All right.
Okay. I'm done now, so that's just the India opportunity. A quick look at that, and then I'm going to park this out here.
Very good. Thank you very much, Harvinder, for that. I really want to shake up the discussion a little bit and get a good debate going here. Ajmair, if I can come to you. Astranis is, I I think it's a relatively new company. You're doing extremely exciting things. Can you just give us an overview of what you're doing and how it relates to 5G?
Yeah, thank you, Aarti. And first of all, thank you to SIA and inviting us here. And it's already been a remarkable conference. And thanks for Harvinder for the overview. And in the time we've got left, I want to share with you a little bit of Astranis also. And so we're a young company. We've been around for about 7 years. In that time, as you know, we've had some quite notable milestones, which I'll share with you in a second. But just to explain, what does Astranis do? We build small, reliable, dedicated micro geosatellites. So everyone's familiar with the established geosatellites, which are very large, size of a bus. And what we build is more akin to the size of a dishwasher, and it's about 420 kilograms. And what we're doing is focusing on building a production line. And we have a facility in San Francisco, which is about 180,000 square feet. And we're building a production line whereby we are to produce more than 20 satellites a year. And a common topic throughout the conference so far has been focused on software defined. And that's exactly what we're focusing on. So we'll be implementing continuous improvements. And the difference between us and the historical established business industry, if you like, is historically somebody builds a satellite and then somebody else operates the satellite. What Astranis are in business to do is we're very vertically integrated, and we build and operate. And so what that means from a practical and commercial point of view is we can get satellites into orbit in a very short period of time. From order, right now it's 2 years. We're working to reduce that to 1 year. Secondly, we are reducing the barrier to entry into SATCOM's business. And let me explain about that. Right now, historically in established models, it takes a long time to build a satellite, a lot of capex, a lot of risk on a given service provider in a given country or a given government. What we do is akin to like leasing a car. You put a small down payment, then we go and take all the risk to finance a program to build, manufacture, test, insure, launch a satellite, and a given operator in a given country doesn't pay anything from that initial down payment until 2 years when we're in orbit, in operation, commercial operation. And so that means when a given operator in a given country, their business is running, that's when an OPEX model flows. And just to share with you one more thing is we don't build satellites that last for 15, 20 years. You know, how much technology do we have that we carry in our pockets and our laptops are built for 15, 20 years. So right now, what we do is the service life is 8 years, the design life is 10 years. And like I say, we're essentially selling satellite capacity as a service. So say after 8 years, all that happens is you continue your subscription, and we go change the satellite with the latest technology, with increased broadband, and we're in business. Our whole purpose business is to be driving down constantly the cost of the space segment. And when I come to India, I used to be in the DTH business once upon a time, and I saw there when originally set-top boxes were $60, $70, $100. Now it's less. A set-top box costs less than a cup of coffee. We're doing that space segment, and we're working with partners in a non-proprietary fashion to do that, to drive down the price in the ground segment also. Just last point, as a last introduction to Astranis, 7 years old, however, we're well backed and well funded. Some of the accomplishments we've had this past year is we completed our Series C funding, where we've raised more than $400 million at a valuation of $1.4 billion, with very notable tier one investors like BlackRock, Fidelity, Andreessen Horowitz. And the reason we can make these claims whereby we can really drastically reduce the cost is because we've got the backing to build something for the long term. And the very last point I want to share is, I was on a conference in Korea last week, and the moderator asked me, he said, that sounds great, but it sounds almost too good to be true. And so I answered that question then, but I want to share that answer here today as well. The difference between what we're claiming is that we name our customers. Our announcements are real. Our first customer launch is at the end of this year. It's a company called Arcturus. The satellite's called Arcturus for a company in Alaska. That's for a satellite broadband application. We've sold 2 to Anuvu in America. That's for in-flight Wi-Fi connectivity. We sold 1 to Andesat in Peru. That's for satellite backhaul. And in reference to this particular panel, we're in our sweet spot. We're not doing broadcasts. We're focused on satellite broadband, and we're focused on cellular backhaul. So 3G, 4G, 5G, it's right in our wheelhouse. And so we're focusing on where all the growth trajectory is going, and not where maybe historically satellite has gone in the past.
Excellent. Thank you, Secy. Now, the parent company of Hughes, EchoStar, has been focusing on the standards in 3GPP. They've done a lot of work to make 5GNR over NTN a reality, and we've seen a lot of announcements around direct access from satellite to smartphone. That's like the holy grail of satellite, right? We don't know whether it's real or not, but it's certainly very exciting, and there's many companies who are trying to go for it. Do you see this direct to handset as somehow a threat or an opportunity, and how real do you think it is for the Indian market? Can you share your thoughts?
Hi, I may or may not need the mic. Anyway, thanks for the question, good question. So let's start off with the fact that direct to smartphone or equivalent is not new. I mean, Hughes has been building direct to smartphone technology for 20 years. I worked in 1998 on the Thuraya program, which was specifically that, and it was built on open standards. What is changed now with 3GPP getting into it is that up till now Hughes is not the only one, there have been others who have been building this. In one sense, satellite direct to home is still in the dark ages, okay? Because you buy a phone which works with Thuraya, it doesn't work with anybody else. You buy a Starlink receiver, it doesn't work with Kuiper, it won't work with OneWeb. So this is crazy. I mean, if this has been the way terrestrial cellular had worked, you wouldn't have iPhone, you wouldn't have these fantastic sub 10,000 rupee smartphones that people sell, because a satellite operator ends up having to do everything. He builds the handsets, he builds the ground station, he launches the satellite, he runs the satellite, he builds all the testing equipment, which by the way is easily 30-40% of the development cost of a satellite system. Now, 3GPP coming in and standardizing NTN basically means that this whole thing gets sliced, right? You have maybe Agilent will build you a tester, Qualcomm will release a chipset which supports NTN natively. Somebody else will take that chipset and put it into a terminal. You'll have sub 10,000 rupee handhelds which can actually talk to any satellite which obeys NTN. So in terms of opportunity, it's a gigantic opportunity, right? Satcom manufacturers can focus on that which they believe. When they launch a satellite, they don't need to worry about worldwide coverage, because they can partner with other compatible Satcom operators. The threat is that if you have any assets today which are not NTN compatible, they will instantly get liquidated. They are worthless at that point, they're a liability. Because, the day Qualcomm or MediaTek or somebody similar launches a chipset which obeys NTN, nobody will go out and buy, a smartphone which doesn't have that. That will become the standard. If iPhone puts an NTN capable modem into their phone today, that will become the standard. So it's a gigantic opportunity on one side. It's a threat to, especially if a Satcom operator is making money out of selling the terminals, it's a gigantic threat to them. That's my viewpoint.
Excellent, thank you so much. Shrivastava ji, if I can bring you in, you were talking about your partnership with Inmarsat. At the end of the day, whether it's 5G or now we're even starting to talk about 6G, at the end of the day, these technology developments, in my view, are worthless unless they're going to transform the lives of people on the ground. So BSNL has a mission. You are trying to bridge a digital divide. How hopeful are you that satellite will able to actually spread 5G also? So we're not just talking about basic connectivity. I mean, Inmarsat has been doing satellite phones for many years. We've just heard a big commenting on the possibility of 5G to smartphone as well. So how hopeful are you that this will penetrate across India?
Yeah, absolutely. As you have rightly put in that Inmarsat was there since quite some time, and we had an agreement with that. But those days when I was looking after BSNL, Inmarsat was playing a complementary role. Where terrestrial network cannot reach, Inmarsat has to be brought in. But as I had mentioned that after the launch of 5G, I think it is going to be extremely impossible for the MNOs to spread 5G network across the country, let alone in city areas, without the help of NTN network. And as my colleagues and you have also some time back put in that 3GPP and IMT documents are going in that direction only, that satellites are going to be the integral part of the development of 5G expansion, both in terms of mobile broadband and in terms of many other activities that is going to come along with 5G, because 5G is not just higher speed broadband, it's an inflection point which is going to touch each and activity that we do in our society individually or otherwise. It's going to touch everything. And without the help of NTN, I don't think it is possible. And I'm very hopeful that sooner rather than later, MNOs will have to tie up with NTN network or the satellite network to expand their net.
So let me stay with you for a second, and I'm sure Tony will have something to say about this. I mean, we know that Bharti has an investment in OneWeb, so does Hughes. So you do have NGSO interests which may help as well in India. However, from what we've seen even with 3G and 4G, the mobile operators in India still have not bridged the digital divide. So what confidence can we have that they will really leverage satellite to try to do this? Can we rely on the investment that companies like Bharti have, for example? Can we count on that to for them to actually make a difference in India, or is that just a financial investment?
Well, initially, before the private operators were very big players. Somebody mentioned that as per the size of India, number of operators are still too less. But initially, there used to be about 14, 15 operators, and the role to bridge the digital divide was on the shoulders of the government operator, which is BSNL. They were only supposed to invest in rural areas, lay optical fibers, and my experience was that no matter what you do, whatever you spend, you take the optical fiber to say one particular point, and there are 6 times more villages around that. And it wasn't possible to really give the mobile broadband connectivity to each and every individual in the villages. That was not possible. But now, this investment is coming through private players. Jio and Airtel, I think they have the plans to tie up with the satellite companies to spread the mobile broadband in rural areas. I think they have to do it, and there is no other go. And there is a lot of pressure from the government also, because Digital India, you see, the Honorable Prime Minister has launched Digital India, which means that you have to be connected all the time. And I'm sure that in your organization also, the concept of right to connect is, becoming a very powerful word, because unless you are connected, you can't exercise any of the rights as enshrined in our constitution. So right to connect is extremely important, and therefore all the private operators, government, BSNL, BBNL, they'll have to put their foot forward to ensure that this digital divide which existed and which is now even more with the introduction of 5G is going to be fulfilled.
Thank you. We may come back to that point in the Q&A if we have time. Alec, can I bring you in? A lot has been said about the capabilities of satellite. A lot is riding on what satellite can actually deliver in terms of quality of service and performance to support the MNO requirements and ultimately consumer requirements. In India, consumers have been spoiled. The MNOs have done amazing things in making connectivity affordable, and therefore we can imagine that their requirements and their demands from satellite operators, or from the satellite sector, should I say, because we shouldn't be distinguishing between operators, etc., when we come to astronomers, right? We can imagine that those demands are also going to be quite high. So what can you say about the next generation of satellites that we're going to see from Astrana's point of view? Will they be 5G ready? What kind of latency QoS can we expect from them?
Yeah, so at Astronis, we exist to drive the cost of the connectivity down as far as possible. That is our entire mission. And the way we do that is by getting efficiency in every component of the system. As Alex mentioned, we are trying to provide the service not just from the satellite perspective, but from the ground perspective as well. So how do we get that efficiency? We get that efficiency by putting the processing power in an appropriate place. And that does not, for us, that means that the spacecraft exists as a physical node, but it is not doing the high processing power requirements. So to get really low cost bits per second to the ground, I think the future is going to be some hybrid connectivity where the satellite exists, it has some small amount of processing, but there's still a terrestrial processing that is being done because of the cost of research around that.
Excellent. And I think India is a great example of where the affordability question really, really matters. So Abhi, can I bring you back in? In your view, what kind of an impact is satellite innovation, satellite technology, and the NTN standards going to have on terrestrial network infrastructure in the future with regards to cost reductions and so on? We know that many MNOs are now reducing the number of masts as well, also because with 5G, the energy is meant to be a consideration and the cost associated with that. And they're trying to reduce also the number of nodes B because of the high cost of energy. We even hear about companies trying to put G-node B in the sky, right? So what can you say about that? What impact is satellite technology going to have on terrestrial infrastructure going forward?
Well, first of all, and people should jump up and disagree with me. I think the future of satellite has to be LEO. I mean, GEO is pretty much at the GEO is always going to end up playing a second fiddle simply because of the capacity constraints. Now, I don't say this lightly because there are hard problems to be solved with LEO, real law of physics issues, trade-offs mostly, as opposed to problems which have a solution. But if you have, if you can raise the funding and build an open standard-based LEO-MEO joint constellation, that can provide a significant supplementary and even, it can reduce the load on the terrestrial network to a large extent. And of course, we are not there. I mean, I expect sometime in the next 10 years, the technology may mature. But if we get there, then yeah, a lot of first of all, the rural connectivity issue, which has been raised earlier. I think part of the connectivity, and I keep harping on this point, is that you can't go and sell, a clunky terminal this big, costing 100,000 rupees into villages. Even if they have the money, they're not going to go for it. They want the same sleek, handsets that they see advertised on TV. So they want cool, 10,000 rupee handsets with, big screens and stuff like that. But other than that, yeah, the pressure of building out masts, for example, there was a time when there were 130,000 masts just in the NCR area. The pressure of providing capacity both at peak and off peak. That is something that, in fact, we tend to overlook. But for technically, that is an enormous challenge. The vast difference in peak and off peak. India is a vast country. I mean, if you just talk about, and we talked to one of the Indian satellite players some time back, connecting to 250,000 villages or district headquarters, the capacity requirement is enormous and it varies dramatically. The last thing I would like to say about LEO, why it is exciting to me, is that GEO satellites, there are 5-ton satellites which are launched with a design life of 10 years. Now that's great for satellites maybe, but as a communication payload, as a communication engineer, that's terrible. I mean, and Etsy will not work with that either because our technology gets obsolete in 4 years. Never mind, lasting 8 years. And LEO satellites are designed with a design life of 5 years. So effectively, every 5 years, I get to upgrade the technology, which has to happen in order to keep up with terrestrial, right? Terrestrial refreshes their entire network every 3-4 years. They just build new stuff. Etsy is going to come up with a new release every 2 years, right? And you have to keep upgrading to solve that. So whether it is by using software-defined satellites or whatever, this pace of technological innovation has to catch up in the satellite domain, which of course is another big challenge. But this is what I see.
Thank you. With your permission, I want to go until 1:20. I hope that's all right, another 10 minutes. Yeah, thank you. Ajmair, can I just bring you in on the same point?
Yeah, thank you. Look, I appreciate the perspective, and I just generally caution against any absolutes. When it's quite bold statements that an established technology like in GEO is done and it's all going to be LEO. The opposite is also not true. It's a big market. There's a lot of applications to serve, and there's something there for everyone, including a mixture and a hybrid. It's very difficult to fathom that, in one hand, the bold operational cost of sustaining a global constellation or even a local constellation, whereby a LEO satellite is designed for 4 years, which means, just imagine that means every year you have to replenish and change 25% of your fleet. And it just takes a disruption in supply to space to really have an impact on that. But it's just difficult to contrast that with the statement that, hey, we need to reach rural areas and villages, and they're not going to, the price points for ground segment isn't relevant for that. The speeds aren't relevant because, let's not forget, and I know we're on a 5G panel, but, right now, 5G is applicable to like less than 5% of the global population, and actually, especially where we are, 3G, 4G, and data rates that enable e-commerce, telehealth, enable people in remote areas to get access to service that we've all been used to over the last 10, 20 plus years. It's good enough, right? And so, in any case, it's a great perspective, but I think it's exciting to see the evolution of what's happening at all constellations. But I think there's something there for everyone right now.
Thank you, and
Aarti ji, organizers also wanted, there's one gentleman sitting amongst us, Mr. Aditya Krishna. He's a scientist from ISRO, and he has been the winner of a research paper competition conducted by SIA-INDIA. And they wanted that, and his topic was maximum revisit time computation for satellite constellation. And organizers wanted that he should be given 5 minutes to present his paper because he's a winner.
Okay, we will allow him to do that in just a few minutes then. Thank you. I agree with you, Ajmair, about it being a big market and actually room for everyone. We have to remember that half the world is unconnected, and when you bring 5G into that, it's even worse, of course. But when it comes to 5G, we need to remember that while satellite is very bold and it almost looks as if we compete with each other, the different companies and so on, at the end of the day, satellite is not going to be the driver behind 5G. It's going to be the telcos, the MNOs who are in the forefront. Now, we know that chipset manufacturers like MediaTek, they've done the tests. They know what works already with existing GEOs. They know the potential of LEOs and so on. But at the end of the day, it's going to be when the mobile operators want to buy or produce phones which have those chipsets that is going to take off, right? So I would like to bring Tony in from OneWeb at this point. No? And anybody else from OneWeb here in the room? No? Tony, can you put a OneWeb hat on for 2 minutes? No? All right. Well, the question I wanted to raise, and let's see if anybody wants to comment on that, is mobile operators like Bharti, like GEO, etc. We need them to be the ones who are driving this in markets like India. So how hopeful can we be that they're going to do that? We know that that technology is ready. We know the chipsets are effectively ready, but the demand has to come, the pull has to come, right? Anybody want to comment on that? From the audience, from the panel? Abik, please.
Yeah, I was reading the NTN specs last couple of months actually, coincidentally. And when I read 38133, 38233, the first thing I look at, who's the author. So the author was from Qualcomm, and he had a smattering of other people with him. But yeah, you're right. There was no representation from Deutsche Telekom or Bharti, or maybe they are involved in the panel, I don't know, but they were not listed in the name of authors. So, yeah, we need telecom operators to push in, and this is also, of course, a financial angle, because telecom operators and satcom operators tend to live in separate worlds. But we need OneWeb is a example of when that is not correct, because of course Bharti is involved in that, and we need people like Bharti to drag these people screaming to the table, make them sit down and participate in the standards. Because it's not just about, you know, MediaTek or Qualcomm. For MediaTek or Qualcomm, this will be a tiny fraction of their business. I mean, it's just something that they add on. They will sell chips regardless. But you have gateway vendors, you have got network side mod-demod vendors, you've got people like Marvell, you've got people like Philips or TI, and they're all looking at telcos to set their hands up and put their hands up and say, yeah, we are going to be investing in this, we are going to be buying these chips, so you start the design and the research life cycle right now. And of course, you guys will know how much of that is happening, but the indications are it is still vague at this point of time.
Thank you very much for that. Harvinder, you want to come in?
Just going to quickly make a point, just to reinforce my technology side of things, even the OneWeb's in space right now. There are issues.
Hello?
Oh, hello. Right. So you have to understand that the LEO satellites go around the Earth, and you only go about 2.5 minutes. Sorry if I'm going very detailed. And you only go about 2.5 minutes before you make a break. So the technology is kind of slightly lagging in terms of even, you know, user terminals at the handheld level. So all these sectors, the semiconductor section has to come and work hand in hand with the operators to make sure that it makes a product which is usable. It's not like you deploy something very quickly and then suddenly you launched it and you got nothing which lacking the functionality it was originally meant for. So that's only my point. So hence the standard has to come after that once all these technologies been proven, I guess. So.
Thank you very much for that thought, Harvinder. I'm going to come back to the chair just on a closing question. In many parts of the world, there is a race for 5G. In a country like India, where half of the country is still unconnected or very, very poorly connected, what is the race? Is there a race for 5G, or is it still a race to bridge a digital divide?
Well, it's kind of both, because you can't leave aside bridging the digital divide, and at the same time you can't be lagging behind, catching up with new technology. So in India, it's always like that. So India lives in two dimensions, like one is rural, another is urban. And whatever you see, whatever infrastructure you see here, it has got two dimensions. You are bringing expressways and highways, and you are bringing fast trains at the same time. And when you go to the rural areas, you find hardly, you know, motorable roads. So this distinction is always going to be there. But yes, it has to be both ways. That digital divide has to be met, should be given a slightly higher priority, because we have gone very big in digital. Everything is digital, whether you do banking or whatever you do, it's digital these days. And the poor folks who are living in rural areas, if they can't enjoy those facilities, it is going to be very difficult for them to integrate with the rest of the country. So both are required, but I'll probably put bridging the digital divide in number one spot rather than going for the competition. Although we tried to launch 5G, and I remember when I used to say that when the world is launching 5G, we are going to launch together, but we are already now 2-3 years behind. World has gone ahead, but it is still better late than never. We have come back, and 5G is coming to our country. So that's what my thoughts are.
Excellent, thank you very much. I think we just need to remember that 2G, much cheaper technology, did not achieve it. 3G did not achieve it. 4G did not achieve it. And I note Ajmair's point that it's actually people are very happy when they have a good functioning 4G. Will 5G achieve it? The jury is out. But on that note, will you please join me in thanking our panelists for a very interesting discussion? Thank you.
Thank you. And if you bear with me, organizers wanted this gentleman, Mr. Aditya Krishna, who is scientist from ISRO, the winner of a competition. I'll give him 2-3 minutes to put forward his views here.
Very good afternoon to the honorable speakers present on the dais and to everyone present here. My name is Aditya Krishna. I am from Indian Space Research Organization, and I've been invited here to present my research paper, which is titled Maximum Revisit Time Computation for Unsymmetrical Satellite Constellations. So in purview of time, I'll keep it brief and I'll jump right into it. Just coming to the introduction, the world today is witnessing a rapid increase in remote sensing satellites and constellations in LEO, MEO, and every year. Example, Starlink and OneWeb, which was recently launched, which has been a primary indication in many of the discussions today. So one of the key parameters for designing such a constellation is something called as a maximum revisit time. So revisit time, as the word suggests, is a duration required for a satellite or a constellation to acquire, produce successive images of a given location on Earth. So given, suppose Delhi, if we want to image it, what is the time for a satellite to image Delhi in successive successions is what the revisit time actually is. So the question is, what role does maximum revisit time play in constellation design? So MRT, maximum revisit time, generally, if you want to image a location within a day, so the satellite should come upon the location to image it within 1 day. So it should not be more than that, 1 day or less than that. So that is the maximum revisit time we should design the constellation for. So suppose for GPS, we want every continuous update of the location. So we want the maximum revisit time to be 0 seconds. So that is what the parameter says about it. So generally in literature, the various numerical as well as analytical algorithms proposed to compute the maximum revisit time are for symmetric constellation structures. Suppose something called as a Walker constellation. But the provided formulations are not applicable for unsymmetric constellations with difference in the RAN, which is the right resonance to resonance node, and the mean anomaly. Just to make the audience clear what exactly symmetric structures are, this is just a schematic of showing what the how an orbit is determined, the parameters for an orbit. So the RAN here is suggested as an omega here. That is the plane difference. So 360 divided evenly gives the number of symmetric planes, and the true anomaly here is evenly divided into the entire orbit, number of satellites symmetrically distributed. So that is what a symmetric constellation actually is. So I'll go back. So with the advancements of field of space technology, unsymmetric plane phasing constellations are being introduced to meet the mission requirements with minimum number of satellites to optimize the utilization of resources. So in addition, existing symmetric satellite constellations are becoming unsymmetrically phased constellation due to decommissioning or deorbiting of more and more satellites. So the objective was to develop an algorithm to compute revisit time for various LEO satellite orbits, sensor geometries, and satellite constellations of circular electrical symmetrical configurations. So the algorithm uses a time propagated coverage-based access formulation to compute the revisit times, and it has been verified with general numerical orbital symmetry software generally used around the agencies, STK. So the results were actually quite promising. So here we had literature comparisons with a few of the literatures, and we had seen very close match within 0.1% error as you can see, the literature results and the obtained results here are very in close match, within 0.1% error. And so basically, these are the results for unsymmetrical satellite constellations. The previous one was symmetrical. So this has been not yet researched upon much, and we were seeing with the developed algorithm, the results are matching very accurately to the actual unsymmetrical simulations in STK. So we can use this in future missions where decommissioning or deorbiting of satellites happen in a given constellation, which makes it unsymmetrical, and we can optimize the satellite configurations for obtaining revisit times, maximum revisit times to reduce them with the existing satellite constellation instead of replenishing satellites via many launches. So the conclusion is that the remote sensing constellation provide valuable data for various applications around the globe, multiple applications. So to meet the never-ending global demands, the number of satellites that are launched is steeply increasing every year. So considering new demands, mission requirements, unsymmetrical plane phasing as well as unsymmetrical in-plane phasing constellations are being planned. So the present study is developed as a methodology to compute the revisit time for unsymmetrical constellations, and the results are verified with the existing literature and STK results. And the comparison is that the error percentages we are observing is less than 0.1%. And this method can also be used to compute maximum revisit times for existing constellations, where one or more satellites are decommissioned or are inoperable. Thank you.
Yep. Thank you, Aditya, and congratulations to you for winning Research Paper Competition Award by SIA-INDIA.
Thank you. Thank you.
So if there are any questions from the audience to any of the panelists, a quick one.
Yes, hello everyone, hello everybody. I'm actually a space enthusiast. I've worked on many space projects, and I'm very thankful to all the fraternity, to the President, the Director General of SIA-INDIA. And let me quickly get to the question. So my first question, this is especially to Mr. Anupam. What are the challenges that are, faced by launching a satellite and then communicating with the help of satellites using 5G?
Wow, India has a great future, I must say.
Thank you, sir.
A round of applause for. So you didn't say your name.
My name is Venkat.
Venkat, okay. Venkat, this is a very difficult question, and I'm sure it is difficult for me to answer. But the challenges of launching satellite, I think the panelists have mentioned. There are challenges for launching GEO satellite, and there are challenges for launching constellation of LEO satellite. So that being said, but they also said that the cost of launching is also reducing in a very, very big way, and the industry is going to drive. Big players are driving satellite industry, satellite communication, and therefore, in the course of next 5 to 10 years, we are going to see the satellite communication, or NTN they call it, non-terrestrial network communication, to play a very, very important role to give you broadband, etc., on your mobile handset.
Got it. And I have another question. This is for all the panel members. I wanted to ask that if I were to launch a satellite, then which should I prefer? And when I say satellite, I refer to, of course, internet and communication satellites.
First of all, Venkat, thanks for the question. Thanks for it's really impressive to see. Before I answer your question, I'd like to ask. One day I want to work for you. So remember me when I grow up. I'd like to be like you, actually. So look, it's a really interesting question you ask in terms of and it dovetails nicely with a point I was trying to make earlier on. I don't know that there is one solution for all things, okay? And so, there's pros and cons in every constellation, be it cost, be it throughput, be it latency, be it time to market, be it the operational cost of developing it and then maintaining it. And so really it depends on the use case and application. If the application is to connect the interconnected, Aarti mentioned earlier on that 50% of the world's population aren't even connected. They don't need a lightning fast connection that costs like, $100 per month. It's not relevant. So it depends on the use case and application, really.
Yeah, no, I was actually specifically talking about, the communication satellites, as if we were talking today, like about launching 5G satellites.
Yeah, the panelists don't know it. Well, launching 5G satellite, as you mentioned, one of the panelists mentioned that it has to be LEO satellite, the LEO satellite which is in the range of 200 to 1,000 kilometers above the Earth. And they have to be in very big number. Initially, OneWeb said that probably there has to be at least 1,000 satellite in LEO orbit to cover the whole Earth. But now we are listening that thousands and thousands of satellites are being launched. But these days, these satellites are very light in weight. And as you must have seen that last week only, India has launched a biggest satellite along with constellation of a smaller satellite. So these constellation of a smaller, isn't it? So we were all proud of it, that we could do it, ISRO could do it. And now these LEO satellite could be a partial payload along with a bigger satellite. So the cost is going to be really coming down very soon. And as I said, industry is driving it. Whatever industry drives, it succeeds. That's what happens.
Got it. Thank you, sir.
Yeah, absolutely.
Venkat, let me come back to you as well with a few different points. One thing is, when you are grown up and working for a company, and if you're in the position of deciding what to launch, first thing is, we don't know what space is going to look like 10 years from now, 15 years from now, or even 5 years from now. We really don't know what situation the space environment is going to be in. That's going to be part of your question, part of your considerations, okay? Another thing which is really important is you can do a lot with geostationary satellites, with meostationary satellites, and with LEOs. You can do a lot with all of them. The biggest problem standing in between the world being connected and not connected is not the lack of technology, it's the lack of policy. It's that governments are not putting the frameworks in place that really encourage everybody to be connected. So I'm really thrilled that you as a youngster are asking about satellites. We want the younger generation to put more attention on satellites and make more noise about it in front of governments, because they need to put favorable policies in place that make sure that satellites can do what they do best. So please keep it up.
That's very true. Thank you.
Thank you very much. I think we don't have time to any other question, but that gentleman has raised his hand long time back, so we give him one opportunity.
Thank you. So first I would like to thank the panelists. I think the topics touched on all very, very critical. I have only two questions. Let me make it very straight. Myself is Sivakumar from Antares, and we are developing a software-defined satellite framework on this, because this question is very relevant. So Mr. Abik partly touched upon this. So we talked about the 3GPP2 standards, right, for these 5G, and even today we do not have such kind of a solid standards for the SATCOM. That's our current position. So especially when we are talking about launching thousands of LEO satellites, right? So we do have a CCSDS specifications, but they are not as rigid as the 3GPP standards, where we can say we can currently interop with these ground stations and then the radio modules in the satellite side. So my question to the panelists is, how are we going to address this concern when we are going to be launching like thousands of LEO satellites? How we are going to be standardizing the CCSDS as equivalent as that of the 3GPP, where the interoperability will solve the problem on its own based on the specification, not based on the manufacturers.
Abhik, would you like to take this?
I don't know much about CCS,
I can make some comments, but they're not necessarily, the end goal here is to connect people on the ground using their phones to a network. And to the point I was making earlier, that may be by putting 5G protocols in space, it may not be. So from our perspective, by leaving the satellite as a relatively just physical link layer connectivity and using that as a cellular backhaul component and letting the ground do the 5G connectivity component, that might be the most efficient way to have the system overall connected. So that might be the preferable manner to move forward, and that would be where the standards come in. And in that case, there's no new development required for the space asset as well.
That the current, industry is going to be following to address this concern, to upgrade this, satellite already on space for the speed in which this 3GPP spec is going to be evolving. And we, as an Antares, developing this software-defined solution for this satellite, and how that can be adopted by these industries, right, in a wider manner, where we can quickly reach out, updating this satellite for the flight software as well as this radio software, which is very, very critical for this communication network.
Yeah, thank you, Alec. Thank you, Ajmair and Aarti. Thank you for accepting in the last moment being the compare for the function. Thank you, everyone. So I think we finish at this point. Thank you.